All right, today we are going to be talking about inverses and how to solve in order to find the inverse of a function given. Okay, but the first thing we're going to remind ourselves is just how to evaluate some functions. Okay, so let's talk about numbers 1 and 2. So in number 1, let me zoom in. In number 1, again, it's giving us a function. Doesn't matter the variables here, just h of a equals this expression right here. Okay, so we have a plus 4. And then it's asking us to find h of 10. So notice instead of an a inside the parentheses, it's now a 10, which means we take that 10, we plug it into the a spot, and now it becomes 10 plus 4. Okay, so this is our f of 10 becomes 10 plus 4, which equals 14. Okay, so basically, given a function, plug what it tells you to plug in, where it tells you to plug it in. Okay, number 2. So now we have our function, h of x, and instead of an x, we have a negative 5. So here I have two x spots that negative 5 needs to go into. Okay, so this is going to become h of x, or excuse me, h of negative 5 is what we're trying to find, equals negative 5 cubed, used to be x cubed, plus 4 times negative 5. Okay, so the first thing we got to take care of is this negative 5 cubed. Now, whenever we have a negative and it's being taken to the power of an odd number, in this case 3, we know our answer is going to be negative. But we can go ahead and just punch this right into our calculator. Make sure, though, you must include the parentheses. So parentheses, negative 5, parentheses, to the power of 3 gives me negative 125. If you did not include those parentheses, you would have gotten a different answer. Actually, you would have gotten the same answer. Well, oh well, yeah, include the parentheses. Thinking out loud here. Alrighty, okay, so we have negative 125 for that guy. Then we multiply 4 times negative 5 gives me negative 20. Okay, negative 125 minus 20 more is negative 145. And there we go. Okay, so for numbers 3 through 6, it's asking us to perform the indicated operation. Okay, so notice now that we're given two functions. We have g of n as this guy, and f of n of that guy. Okay, now what is it actually trying to have us find? Find g of f of n. Okay, so this means we are going to multiply. Actually, I'm going to just change that to a multiplication symbol, just a dot in there. Okay, so I'm going to change that to make sure that we're multiplying. Okay, so now I have g multiplied by f of n, which means I'm going to take these two functions and I'm going to multiply them together. 2n plus 2 times by negative n. Okay, and remember, whenever we multiply things together, every term has to multiply to every term. So 2n has to multiply to the negative n, and 2 to the negative n. Okay, so I have 2n times negative n gives me negative 2n squared. 2 times negative n, negative 2n. The only thing we would have to do further is see if we can combine like terms. We cannot, because n squared cannot be combined with just n to the first power. So that is our answer. Okay, so now let's look at number 4. So we're given our two expressions, our two functions, and we're asked to find g subtract f of t. Okay, so we are going to take our g function first, t squared minus 2t, and it wants us to subtract our f of t function, so negative t. Notice that I'm subtracting even though it's a negative. You must include all of those negative signs. Okay, so now what we do is I see that I have a double negative here. So this is actually going to turn into a positive t underneath. There's nothing I need to distribute or multiply, so I can just go ahead and get rid of the parentheses. Okay, and again, my very last step is to see if I have any like terms that I need to combine. Here my two like terms are negative 2t and plus 1t, because they both have t to the first power. So we have t squared, negative 2 plus 1 is going to give me negative 1, or just negative t. And there we go. Okay, looking at number 5, we have our two functions, g of x and f of x. It's asking us to find g plus f of x. So we're actually going to add these two functions together. Okay, so I have g of x, 3x cubed minus 3x squared, and I'm adding it to f of x, 4x minus 1. Okay, well, we have an addition sign. If you remember from last year, the addition sign, we keep the signs the same. So we can just take, we can get rid of the parentheses. So plus 4x minus 1. Then I have 3x cubed minus 3x squared. Okay, now I just need to see if I can combine like terms. Okay, well, I have an x cubed, no other x cubes. I have an x squared, no other x squareds. I have an x to the first power that I can't combine, and just a constant. So that guy is actually fully simplified. Awesome. Okay. Now we have number 6. Okay, so again, I'm given my two functions, and I'm asked to find f plus g of x. Okay, so I'm taking my f first, so I have 3x plus 1, adding it to my g of x, negative 2x minus 2. Okay, and again, we have a positive sign or an addition sign in the middle, so those signs stay the same after it. So now we have negative 2x, negative 2, just get rid of the parentheses, 3x plus 1. Okay, and now we need to see if I have any like terms that I can combine. Well, I do. I can combine 3x and negative 2x. 3 minus 2 is just going to give me 1, or just 1x. Then I have 1 minus 2 is going to give me negative 1, so x minus 1. Awesome. Okay, so here comes the new stuff. So we're asked to find the inverse of each function. Okay, well, this is what it's actually saying with inverses, and here is what I'm going to do. Well, this will make sense in a second. Okay, so an inverse. Okay, so with a coordinate point, we always start as x comma y, right? Okay, that's how our coordinate points are written. With an inverse, they switch. Okay, so the inverse step is to switch the x's to y's, the y's to x's. Okay, so this is our inverse step right there, is to just switch those guys. Okay, so here's what I'm going to do. For number 7 and all 7 through 10, this g of x over here, I'm actually going to rewrite this whole function as y equals, and then the rest of it, negative x minus 1. So that we're dealing with x's and y's. Okay, that's going to make it a little easier. Okay, so now that I've rewritten it with a y, now I need to do my inverse step, which is to change my y to an x and my x to a y. So now it looks like x equals negative y minus 1. Those switched because of our inverse step. So that's our most important step right there. Okay, in fact, let's go ahead and write these steps on the bottom of our paper where we have a little space. Okay, so the first step, we rewrote it. So rewrite using a y. Okay, then we switched the x and the y. That's our inverse step. And now our last step is going to be to solve for y, meaning we want y to be by itself. Okay, so have those 3 steps written down on your notes. Okay, all right, so let's go back, and now we want y to be by itself, so I need to solve for this guy. Okay, so the first thing I need to do is work from the farthest away to my y, so this would, first thing I gotta get rid of is this subtract 1, which I do the opposite, add 1 to both sides. Now, I can't combine x plus 1 because we don't know what x is, so this literally becomes x plus 1 on that side, and we still have negative y on that side. Okay, well the only thing still attached to my y is this negative, or in other words, times by negative 1. So we do the opposite and divide the whole thing by negative 1. Okay, so now I have my y is all by itself. And I'm just gonna flip it on the other side. Doesn't matter which side you write it on. But I had x plus 1 on top, divided by negative 1, which is correct, or we can rewrite it as y equals, that negative 1 changes both signs to that guy. Okay, both of these guys are correct, but notice that is our inverse function. Yes. Okay, I'm just looking at it because it's actually the same as that guy, so I'm double checking my work. X plus 1, divide by 1. Yeah, so that's pretty interesting. Okay, so let's try that again. It'll make a little more sense. So first step, remember, change whatever this is on that side, the function notation, to y. So now we have y equals 5x plus 15. Okay, then we have our inverse. Change the x's to y's, y's to x's. So y becomes x equals 5y plus 15. And now we can solve for y. Okay, so first thing I have to do is get rid of plus 15, which we are going to subtract 15. Okay, we can't combine those two, so we literally just write it as x minus 15, and it equals 5y. Okay, so now I have times by 5 that I need to get rid of. We do the opposite, divide by 5. And everything on that side needs to be divided by 5. So now I can rewrite this over here as y equals, well, x over 5 can be written as x over 5 or 1/5 x, either. Negative 15 divided by 5 is a nice and pretty answer that simplifies to negative 3. Okay, perfect. So let's try that again. So first step, change this function notation to y equals 7x plus 4. Okay, inverse step, super important. X equals 7y plus 4. And now we solve for y. So first I need to do the opposite of plus 4, which would be to subtract 4. So I get x minus 4 on that side equals 7y. Okay, now the opposite of times by 7 would be to divide by 7. Okay, and we can rewrite this guy, y equals, and technically everything's being divided by 7. It's written a little differently than this guy, but the same things are happening. So I'm just going to keep it as x minus 4 divided by 7. And there we go. There's the inverse of that function. Okay, and one important thing to note that I actually forgot. So we actually want to change y back to our function notation, but because it's a function and it's the inverse, we actually write it as f little negative 1 x equals x minus 4 over 7. So this is what you're going to see on your assignment. F negative 1 of x. That just means the inverse function. Okay, so let's try that again one last time. So first step, change it to a y. Y equals negative 2x minus 8. Okay, inverse, switch the x's and the y's. X equals negative 2y minus 8. Then we're going to solve for y. So opposite of subtract 8, add 8. Whoops, I used a different color. I hate it when I do that. Okay, so now I have x plus 8 equals negative 2y. Okay, last step. Opposite of times by negative 2 is going to be to divide by negative 2. Okay, so I'm going to rewrite it over here. I have y is equal to, and again, I'm going to reduce this because 8 divided by negative 2, we can actually figure out what that is. Okay, so I have x over negative 2, which you can't reduce, but then 8 divided by negative 2 turns into negative 4. And the proper way we write this in your assignment is going to be, instead of y, it's going to be g, since it started as g. Little negative 1 of x equals x over negative 2 minus 4. And there we go.